All right, we're going to be reviewing area and circumference in this lesson, which is going to lead us into volume problems. But again, we can't do volume without knowing area and circumference first. So just a review here, a quick review, and I'm not going to really explain this too much because I think we know this already. We know that the circumference is the distance around the circle, and then you can unravel a circle and stretch it out, okay, and then copy that diameter 1, 2, 3 times and a little bit left over, and then you can do that for even a bigger circle. Okay, bigger circle, and then you just copy the diameter onto that circle 1, 2, 3, and then a little bit more. That little bit left over is that 0.14, and that's how we get that number pi. So that leads us to the circumference formula, C equals pi d or 2 pi r. Okay, so circumference is pi d or 2 pi r. That's given to you on the reference sheet, so we don't even have to memorize that. Here's your area formulas that you should already know. Again, given to you on the reference sheet, so it's not like we have to memorize them. I'll give you one of the reference sheets upcoming in a couple days. But here you go. Area of a parallelogram, base times height. A rectangle is base times height. A square is also base times height, but because the base and the height are equal, we just call them S for side, and then we say it's side squared. Okay, so if B and H are the same number, right? If it's 3 times 3, for example, isn't that 3 squared? If it's 5 times 5, that's 5 squared. So we just call it S squared for area of a square. All right. A triangle is 1/2 base times height. That's just because a rectangle or a parallelogram cut in half gives you 2 triangles. So basically, cutting a parallelogram in half is 2 triangles, and that's why you get the half there in the formula. These are all things you should already know coming into the geometry. And area of a circle, pi times r squared. That should also be a review. Area is pi r squared for a circle. So we're just going to answer some questions about area, and then we're going to be done here. The side of a square is 20 centimeters long. What is the circumference of the circle when the circle is inscribed within the square? So we got to draw that out. The circle is inscribed within the square. What that means is, and I'm going to draw it out for you, it means you have a square. It's going to be tough to draw this on this thing I have here, but we're going to do the best we can. You have a square, and then you have a circle inscribed. That means it's inside, but it's also touching the square. Okay, so I'm going to do the best I can here. See how it'll touch it at every, doesn't really look like a circle. Yeah, it's not terrible. It's not great either. But it's a circle inscribed in a square, okay? And so the side of the square is 20. So it's 20, 20, 20, 20. All right, we should know that. Now, because the circle is inscribed in the square, we draw the diameter of the circle. That diameter is also 20. See that? If the side of the square is 20, the diameter of the circle is also 20. That should make sense to you. Okay, so right there to there is 20. So we want the circumference of the circle. Well, circumference is pi times diameter. So it's simply going to be pi times 20. So that's 20 pi. Circumference is 20 pi. Now, we're going to leave it in terms of pi. It doesn't say to do that, but I'm going to leave this answer in terms of pi. If you wanted an actual nearest tenth or something like that, you would just put 20 pi in your calculator, and you could get the actual value round it to whatever they wanted. I'm going to extend the page here to do this one. All right, now for part B, the square is inscribed inside the circle. So we got the circle first, and then the square is inscribed in that. So kind of looks like this. Okay, so what we know about the square is obviously we have right angles here. The problem is we don't have the diameter now, because this is 20, right? This is 20, okay, 20. These sides are all 20, but we don't have the diameter. The diameter, when you do the square inside the circle, the diameter is actually corner to corner. There's the diameter of the square. You got to do a little thinking here, okay? Draw it out, think about it. So if this is 20 and this is 20, basically I'm going to erase, now you don't have to do this, but I'm going to erase what we don't really need. Okay, so this was the diameter of the circle, right? And look what we have. Look what we have. 20, 20, and then the diameter of that circle, okay, is right there. We have a right triangle where we're finding the hypotenuse. Guess what? A squared, B squared, C squared. So I can do 20 squared plus 20 squared equals C squared, and we'll call it D because it's a diameter, D squared. So that's going to be 400 and 400 is 800 equals D squared. And then, of course, we take the square root when we do Pythagorean theorem. So the diameter is the square root of 800. And then we'll just leave it there for now. And then circumference, we want circumference. Circumference is pi times diameter. So it's going to be pi times the diameter, radical 800. Okay? And then all we need to do is simplify the 800. 800 breaks down 400 times 2. And then 400 breaks down 20 times 20, obviously. And there's a pair of 20s. So this is going to be 20 pi radical 2. And that's in terms of pi, and that's in radical form. If you wanted the actual number, the actual value, you could just put it in your calculator, type that right in your calculator, and you would get that value as well. All right. Number 2. In number 2, just want to make sure I'm still thin here. All right. The circumference of a circle and the perimeter of a square are each 50. Which figure has the greater area? Whoa, okay. So circumference of a circle, we have a circle, and the circumference is 50 centimeters, and we have a square. So I'm going to do the square over here. And the perimeter is 50. So if the perimeter of a square is 50, that means it's 12 and a half, 12 and a half, 12 and a half, 12 and a half, 12 and a half. That's because you just divide by 4. Each side's equal, so distance around the perimeter is distance around, so it's got to each be 12 and a half in order to make up 50. That's pretty simple. I think you should know perimeter by now. Circumference 50, that's all the way around. Well, circumference is pi. Let's do, we want radius. So let's do 2 pi r. And if circumference is 50, 50 equals 2 pi r. Divide by 2r. Divide by 2r. And that's going to give me 25 over r. Oh, I'm sorry. What am I doing? Divide by 2 pi. I'm solving for r. That's a pi. Make that a pi. Radius equals 25 over pi. So there's my radius. All right, now I'm going to go over here, back over to the square. The area is side squared. So it's going to be 12.5 squared, and that's going to be, I did it here, 156.25. So the area of my square is 156.25. The area of my circle, area is pi r squared. So it's going to be pi times, and the radius is right here, pi times 25 over pi squared. I could have figured that out if I wanted to, but what's the difference? Now I just throw that in my calculator, and that area comes out to be 198.94. So they might ask you a question like this, okay? And you had to compare the areas, and of course the area of the circle was much bigger than the area of the square, so we would write that. Area of the circle is greater than the area of the square. Okay, and a couple more here. So this one's just a shaded region problem. You just got to kind of, again, think outside the box a little bit, kind of piece it together. They want the area that's shaded. Well, okay, well, I have a rectangle, and then I have two triangles. The rectangle is, base times height. So that's going to be 7 times 3. If this is 3 here, then this must be 3. Okay? So, and this is 7 here. So 7 times 3, and that means the area is 21. That's the rectangle. All right, now the triangles are identical because they're 3 and then 3, 3. All right, so triangles, I'm going to do it on the side here. Area of the triangle is 1/2 base times height, because we do have the base and height now. So we're going to do 1/2, and then the base is 3, and the height is 3. 3 times 3. So that's going to be 1/2 of 9, which is 4.5. So this triangle is 4.5, and this triangle is 4.5. So I add them all together. 4.5 and 4.5 is 9. 9 plus 21 is 30. So 30 is the area of the shaded region. The scaling principle for area. If similar figures A and B are related by a scale factor of r, then their respective areas are related by a factor of r squared. So what does that mean? That means that if I have two figures, they're not even like nice figures. They're just wacky, like whatever. It's 1, 2, 3, 4, 1, 2, 3, 4, 5. It's a hexagon but like not a regular hexagon. It's just a weird shaped hexagon. So two weird shaped hexagons, but they are similar and drawn to scale. So since they're similar, there's a ratio, right? So we have a 2.4, I'm sorry, this is centimeters, this is millimeters. Oh, they almost tricked us there. This is 24 millimeters. Okay, there's 100 centimeters for a millimeter, right? So we got to multiply by 100 here, and that gives us 24 millimeters. Don't do 2.4. All right, so the ratio is actually, and that wouldn't make sense, right? Why would the bigger one be smaller than the smaller one? Okay, so that makes more sense. 24 and 15. So 24 is to 15 as, now, the areas will not be the same ratio as the sides. So here's the ratio for the sides, right? Okay, 24 to 15. That's the ratio for the sides. But based on the scaling principle for area, since area is square units, you have to square the sides in order to get the area ratio. So we're actually going to square that, and that's going to give us the areas. Now, they gave us the one area. Figure E was 120. So we're going to put 120 on top because that corresponds with the 24 for figure E. And then we're finding the other area. So we write a proportion, okay? Ratio equals ratio, sides to areas, but you got to square the sides because area is square units. And that's what the scaling principle tells us. You have to do r squared. All right, so now we're going to do a proportion here. So we have, and I just did this ahead of time to save us time. We have 576 over 225 equals 120 over x, and then do that cross multiplying, right? So 576x equals, it comes out to be 27,000, and then divide by 576. And x, which is our area, comes out to be 46.875. So the area of figure F is 46.875. All right, see you tomorrow to work on area and circumference.